Louise is with Hummink, and he'll be telling us about high precision capillary printing for biomedical applications.
Okay, my name is Caillard. Nice to meet you. I'm going to talk today about high precision capillary printing in a framework of biomedical application using our technology here at Hummink. So Hummink is the leading developer and supplier of high precision capillary printing, which is a technology that has been invented in 2018 in France. The company has been created in 2022 and 2020, sorry, and in 2022 we sold our first tool, and today we are expanding worldwide, selling tools around the globe and trying to qualify our technology for high volume manufacturing this year. In this presentation, I'm going to present the technology itself, as well as some of its applications that some of our partners worked on the last few years in this field. Okay, so first I'm going to focus on HPCaP technology. HPCaP technology is a technology that is inspired from Atomic Force Microscopy, AFM. It differs from it that because AFM typically what you have is that you have a small cantilever that vibrates and use the frequency shift to probe a surface. Here we have tuning fork, which is more macro, makes 10 centimeters wide. And it's resonating in here at 1.5 kilohertz. And once we attach a pipette to this, we can have, I have a little video here to show the thing. We can attach a pipette on top of it, and once it vibrates and we get close to the surface, there is a frequency shift that allows us to see that we are close to the surface, and then a meniscus is going to form and create a cushion in between the pipette and the substrate, which will allow us to deposit some ink. We can deposit some dots like this by retracting and approaching, but also we can deposit some line on the surface, and while we deposit line, we keep track of the frequency, and once it shifts, it can adjust automatically to the topology of the surface, so you can deposit on the surface reactively. You can deposit any shape like this Hummink logo. You can also, since we have a very good unique positioning precision, and like you saw, we only use the capillary force between the pipette and the substrate. So we have no satellite drop. Oh, sorry. We have no satellite drop, so you can target some applications such as repair, such as repairing some damaged line in a semiconductor or display industry, like you can see here. We also have subatomic precision when we are dealing with a very dense array of wires, so you can have a very precise control of the position of the pipette. You can also do some 3D structure, such as pillars, metallic pillars. We have silver, indium, and their shape can vary with an aspect ratio varying from 1:1 to 20:1, depending on what is required. The resolution achieved is dependent on the pipette we are working with. Typically, we work with pipette ranging from 50 micrometers to 100 nanometers. So that will set up the resolution that we can achieve with our technology. And we are compatible with a wide range of ink. Typically, we can deposit metal such as silver or gold or indium, but also polymer or some quantum dots as well. We are developing right now an on-demand module that can be integrated into existing OEM equipment. So that's something that is work in progress, but you also have a tool that more like an R&D tool that can deposit, which is standalone, that you can use in any lab. So what differentiates us from other existing technology is the fact that we are only using the capillary force between the pipette and the substrate. There is no external pressure, there is no electric field applied, so it's a very soft technology, very soft deposition on the surface. So like I mentioned, we can deposit any kind of material on any surface in any shape. And we don't make all this ink, but any ink that